Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily Leetcode challenge, and the challenge name is minimum speed to arrive on time. So the challenge statement is like this: you are given a floating point number R representing the amount of time you have to reach the office. To commute to the office, you must take n trains in a sequential order. So till now what the problem statement is saying is you are given total, let's say, t number of hours to reach office, and then what it's saying is and there are n number of trains to reach the office. You must take these n trains in a sequential order. It means that if you decide to first take the, let's say, first train, you will go in the like this. This is the first, second, and third and fourth train available. You basically they are not available. These you have to take. This is compulsory to take each train, but you cannot take trains like this. You take the first train, and then you take the third one, and then you take the, let's say, fifth one. It's not the sequential order, so this is the wrong order of taking the trains. You should take in this order only: 1, 2, 3, 4 and 5. I hope till now it's clear. And you are also given an integer array, distance of length n, and each element in the distance array represents the distance in kilometers that a particular train ride will take. So what is further given is a train can only depart at an integer r, so you may need to wait between each train ride. What it's saying is, let's say, taking the first train at a particular speed took you 0.3333 hours. Okay, and now when you will take the second train, let me quickly change the color. You will take the second train. If there is other train to be taken at all, you have to take the ceiling of 0.3333. And what is a ceiling? Ceiling of a number is the least integer which is greater than or equal to the given number. So what it's saying is, what is the least integer which is greater than or equal to this 0.333? It's 1. So you can only take the second train after 1 hour, at 1 hour, not before that, because you cannot take the second train at 0.33 hours, just after you have finished traveling from train 1. So I hope it's clear. Now let's move back to the problem statement. For example, if the first train takes 1.5 hours, you must wait for the additional 0.5 hours before you can depart on the second train ride. It's pretty much the same thing which I have told you. And what you have to return is, you have to return the minimum possible positive integer speed. What is minimum integer speed so that you reach office in t hours or given hours. So if you, let's move to the constraints part. And here is the length of the distance array, which represents the distance for each train ride, and order of n is of 10 raised to power 5, and the distances in the distance array are of order 10 raised to power 5, and the number of hours that you will be given to reach the office will be of order 10 raised to power 9. Also, it is given test cases are generated such that the minimum speed that will be possible, or the answer, will not exceed 10 raised to power 7. So it will be our minimum speed possible. So if let's say you are traveling with the maximum minimum speed possible for including all test cases, let's say this is the maximum speed you are traveling in each train, let's say. Then for, if this is the maximum speed, then you want to know what is the minimum speed. Then you can say that from 0 to 10 raised to power 7, there are that many options for speed of train. Whether this much speed would be sufficient or not, that is another issue. We have to check for that. So these many options are available for value of speed. Since we have to find a common speed for each train, so these many options are available. And what's the size of the distance array, how many trains will be given. It will be order of 10 raised to power 5. Let 10 raised to power 7 into 10 raised to power 5, it's 10 raised to power 12, and it's clearly greater than 10 raised to power 8, which are operations allowed in 1 second. So it will clearly give us this brute force approach of checking for every possible speed. Brute force approach for checking for every option available for speed will give us TLE. So what we need to do, we have to optimize this brute force approach. And for those of you who do not know how the time complexity of accepted solution varies according to input size, I'll provide a link for it. Right now what you can understand is this is the article whose link I will be providing to you. And since n is greater than of order 10 raised to power 3 and it's between 10 raised to power 6, so n log n of 1 or log n time complexities will be fine for the solution. So what you will do in order to make your solution time complexity equal to one of these. So basically you, for each distance or train ride, for each train ride you have to check the time taken. That we cannot reduce, but we can reduce the option that we will select for speed. What we will be reducing options that we will check for speed. Initially you were having 0 to 10 raised to power 7 values available for speed, values available for speed of trains, and you in brute force approach you are checking for each of these values. But now what we will be doing is, if you observe, these values are in a sorted fashion. So after 0 will come 1, 2, 3 and so on till 10 raised to power 7. So these are in sorted order. So what we can do for the next choice of speed, we can apply binary search. And since binary search works for in log of n time complexity, n here is 10 raised to power 7, so order of log of 10 raised to power 7 and into 10 raised to power, what is the input size of the distance array? It's of the order 10 raised to power 5. It will be clearly less than 10 raised to power 8 operations. So our solution will be accepted. So how will be applying binary search for the next choice of speed? First of all, you have to understand on for which thing we are applying binary search for. We are applying binary for search for the next choice of the speed. Now let's move to the coding part. There you will be able to understand the logic and the implementation in a more clearer way. Let me quickly zoom out. Yeah, this is the implementation. What we have done is, we have created a helper function, find minimum speed. This is nothing but binary search. And what we have done is, let's say minimum speed, and also it is also told that in the problem statement that if you are unable to reach office in the given time, return -1 to indicate that it is impossible to reach. So initially we are assuming that it's impossible to reach the office, so the minimum speed we are taking as -1, and the minimum possible value of the speed we are taking as 0. And since it's given that answer will not exceed 10 raised to power 7, so I have taken 10 raised to power 7 plus 1. You can also take 10 raised to power 7, that would also be fine. Just for safety I have taken plus 1. Actually that's up to you. Basically it's the same order of 10 raised to power 7. So here I have applied a standard binary search, but here is the trickier part in the binary search. What we are checking is, this is the mid will be the mid is current choice of speeds value. So what we are checking is enough function if the current choice of speed is sufficient to make us reach the office in given time limit, which is r, this value. So in this function we are checking this, and if it's the sufficient enough speed, currently this will be the minimum speed enough. And what we'll do is we'll decrease our search space from one previous value to mid, and right will be shifted, the max limit of the search space will be shifted to one previous to current speed, which is mid. And if that's not the case, the current speed is not enough, we will simply uh, shift our minimum value of search space to one greater than the current speed, which is mid. So this is a standard binary search approach, and at last we will be returning our minimum speed depending upon whether the minimum speed value was updated or not. It will return the answer. And let's have a look at the isNF function, which is checking if the current choice of speed is sufficient to make us reach the office in a given time limit. So what we have done is, what will be the current time taken if the speed is this. So it will be the distance that is to be covered in the train ride at index I and dx, and so this will be the time it will take to do a particular train ride. And if we are not having, if we are having another train to take, then what we'll do, we'll take the ceiling of the current time taken to use this current train, and we'll add the current time taken to the total time taken, and at last we will return whether the total time taken is in the limit of the given time limit, which was r. And yeah, that's pretty much it for the solution part of this problem. Now the code will be available in C++ and Java both. So thank you for watching. Thank you.